Good morning. Welcome to the online version of the session, Version Management with ArcGIS. I'm Annie Sassadar, Product Engineer on the Geodatabase team, sharing this virtual stage with Eric Hull, Group Development Lead, and Kevin Watt, one of the most experienced developers in our team. This session will present some of the technical details behind the new branch versioning model that was developed for ArcGIS Pro and ArcGIS Enterprise. I will take a few minutes to talk about the high-level story before I hand it off to Kevin to give a brief overview on how the database table structure has changed to support branch versioning and what makes this model performant. Eric will present the new version management server, the REST API, and will highlight common workflows from a REST API client perspective. And yes, we do have code snippets that will be available online for you to take and use as reference. So let's take an 8,000 feet view of the branch versioning model. That was Ryan, if you recognized it.
Yeah.
Branch versioning is Esri's new long transaction model, which allows traditional versioning workflows to be performed in a services-based environment. It builds on the well-established capabilities of traditional versioning like multi-user editing, edit isolation in child versions, while also improving workflow management. It is through the version management server capability, the VMS as we call it, key version administration tasks are now performed through services. What are the benefits of moving to this branch versioning model? It is based on the geodatabase temporal model, which archives edits in a single table, so version queries are more performant as there is no need of joining any dependent delta tables like traditional versioning. Kevin will be explaining this concept further in his section. Now, with traditional versioning, it was a required administrative workflow to reconcile versions with default so that the default lineage is not pinned by any version to achieve a full compress. With branch versioning, there is no such requirement. You reconcile a version when you are ready to publish your edits. With branch versioning, the big bonus is that there is no need for compress. Also with branch versioning, we have the ability to directly edit default version in Pro or any version via the REST endpoint without an edit session. Since there is no exclusive lock on the default version, multiple versions can post in parallel. Now, when you enable branch versioning on a data set, archiving is enabled without requiring an additional step. Also, enhanced editor tracking capabilities allow you to track users who delete features within a version, something that was not available with traditional versioning. Also, with branch versioning, conflict resolution can occur over multiple sessions. You can also add notes, comments, mark a conflict as reviewed during your QA process. The REST endpoint has different methods that can be used to perform versioning operations. Eric will go in depth on these and also provide code snippets on how these can be used. If you're using Pro as a client, our team has worked hard on maintaining a similar versioning user experience and the UI between traditional and branch versioning. The version manager is still the view you use to manage your versions. The versioning ribbon and the geoprocessing tools work with branch versioned workspace. All versioning operations are termed the same. You still, as a user, create, alter, delete versions as needed. As a version owner, you set up the access type on the version so that users can either not see your version when it's private, see it but not edit it if it's protected, or both see and edit the version, that is, it's public. You also reconcile when you're ready to pull changes from default version. You detect conflicts, resolve them, and then post the version. But we're having this session because there are some underlying differences between the two versioning models. With branch versioning model, versions are creation and management is available only through services. Now, as a flatter tree structure was recommended with traditional versioning, with branch versioning, this is enforced. You can only create child versions of default, and all versions are siblings. Editing of content is only available through services. So in a client-server connection, you get a read-only view of the data that is branch versioned. In branch, insert, update, and deletes are all recorded as inserts in the underlying table with appropriate timestamps. So this allows us to track changes over time, including deletes. Editing in default version is a short transaction, so it's a last in wins and you cannot undo your edits. When working with child versions, we support only one editor or multiple readers at a time. After you're done editing in your version, when you reconcile, there is an internal save point that happens, and hence you cannot undo the reconcile operation like traditional. On reconcile, when conflicts are detected, you do not need to resolve conflicts in the same edit session as they are persisted. Once conflicts are detected, you can change ownership of the version to the QA person in your organization to continue with the workflow to resolve conflicts, add notes, mark the conflict as reviewed, and then post the version. Branch versioning services can be consumed by any client that works with feature service workspace. The new solutions like utility network, parcel management, roads and highways that we have developed are only supported with branch versioning. Branch versioning support was introduced with ArcGIS Enterprise 10.6. We support all the standard database platforms. For PostgreSQL, Oracle, and SAP HANA, the version is bolded since version required to support branch versioning is different than the minimum version requirement for 10.6. So how to get started? The most important thing is to set up your workspace connection to use branch versioning. You can do that using the geodatabase connection properties. Once you've connected, you add on the dataset, you add global ID, enable editor tracking, and then register the data as versioned. Once the data has been branch versioned, you can connect to a portal as a user with publisher privileges and share the content as web layers and select the VMS capability during sharing. Once it's published, you can consume the published service in a client and continue your editing workflows. We have planned many more enhancements to this model. Currently, with branch versioning, conflicts are detected at row level. In the upcoming release, we are going to allow conflicts to be detected at the field level and also allow sets of fields to be filtered out from being marked as conflict. As we continue to enhance automation workflows in branch versioning, we will develop a version posting queue to which editors can add their own versions once they have completed their editing, and these edits will be posted to default at a later time as part of an admin workflow. Currently, you need to be the user that has published the service or the portal admin to perform version administration. We are planning on creating a custom role that will not require such elevated privilege to perform these admin tasks. On that note, let me hand it off to Kevin to go ahead and talk to us about the database schema and query performance.
Okay, so we're going to talk about the schema and the database queries that power branch versioning. So the data model that we use, like Annie said, is based on time. We use several fields to manage an edit. An edit is based upon a moment in time, which is our GDB from, and its status, whether it's deleted, inserted, or updated, which is the GDB is delete. And we add to it a unique archive OID, which is the unique row identifier to keep the rows separate. The reason for that is that we build indexes on them, and they're primary key indexes, and that key allows us to make these indexes unique. Branch versioning is not new. Branch versioning has been around for several years. It comes from SQL Server's change tracking, which has been around for about 15 years. So the technology we're using is nothing new to Esri or any other database company. As Annie said, time is used and is recorded in milliseconds. We use the GDB branch to define whether we're working with default, as Annie said, or in a named branch. These fields are managed internally by the geodatabase and are available when you're working with the archive class. So those of you who work with the archive will be able to access these fields and build applications on top of the branch versioning model. We, as I said, create indexes on these, and the indexes are managed internally. And now we're going to look at the query itself. So when we add data to a branch table, we add it based on inserts. In this case, we're showing a table where we've got several rows and we're adding them to branch default 0. As I said, inserts, updates, and deletes are all inserted in the table, and a delete is managed through our delete field is delete, GB is delete, indicated by the 1. So the query itself, let's take a look at that. The query is based upon a database technology called analytic functions. Those analytic functions are used to basically aggregate results and filter them based upon functions. So in this case, we're going to start with the internals of the query. We select with the row ID, and the importance of using the row ID is because it's not hitting the table per se. It's using the unique row identifier in the database, which is much smaller than the row itself. So the internals of the query are just powered on that one field. We're going to filter this one by GDB branch ID 0, which means that we're going after the default. In our table here, we show 2. We have branch ID 0 and 10. So now the part of the query that's important to this is the analytic. The analytic is using what's called a partition by and an order by filter. And that is based on object ID. So in this case, what we're trying to do is we want to order our object IDs. We want to partition by our object ID and order it by the from date in descending order. So what that means is that we're going to partition them by the object ID, which is highlighted here in red. We're going to order them in a descending order by its from date. And off to the left, you can see that we're ordering them in descending order, which means that the most current row is the first descending order. So when we execute the query, we want back all of the row number counts, the RNs equal to 1, and we get back those in our query. Another important part of this is that, as Annie said, everything is modeled in a single table. Unlike the traditional versioning where we had an adds, a deletes, and a lineage table to manage the different edit states, everything is managed in the same table. When we add a branch, a named branch, it goes into our branches table, indicated by the moment it was created and the branch ID. From that point on, all edits appear in the same table along with default, as we're showing here in our example. So when we do a query against a table that has both named and default branches, we're able to do it the same way we showed in the previous example. We're going to filter this based upon default and branch. In the highlights, we show both default and branch. We're going to order these the same way, order them by object ID and partition them based upon a descending order of from date. And we're only after the ones that are not deleted. And now I'm turning over to Eric to talk about the version management server.
Okay, that was pretty fast and furious. We've gotten through a lot of material. I think one of the interesting things, hopefully you guys are picking up, everyone listening and watching this video, is that the branch versioning model is pretty streamlined compared to the implementation of traditional versioning that we released with ArcGIS 8. Gosh, when was that? Back in 2000. The queries that Kevin took us through are fairly straightforward. If you sit there and try and tease them apart like Kevin did, you'll be able to say, yeah, they are fairly straightforward, and they're applying some interesting common database techniques and whatnot, ordering things in descending manners and whatnot, in order to essentially instantiate the current moment or any other moment in the system. Now, one thing that's important to keep in mind is, given that we have all these timestamps where things are recorded down at the millisecond level or level of granularity, the the system is essentially a temporal system. You can do moment queries, either the current moment, whatever the last edit was when you're editing in your branch or your version, or you can rewind the system to a previous moment. And so that becomes very interesting when you start looking at the default version, being able to rewind the system and see what it looked like at any moment in time. That's a very powerful capability. But the neat thing about Branch is it's like Annie highlighted and Kevin drove home with some concrete query examples, is how simple and streamlined the implementation actually is. The queries are simpler, they can execute faster, they can be more optimized by the underlying database. So all in all, we see it as a really big win for us. So we're very happy with the new branch versioning model. So let's talk a little bit about services. Services are pretty interesting as an architectural concept. Over the past, I guess, decade, Esri has had a strategic vision to move as much capability as possible to a service-based architecture. With service-based architectures, you have all kinds of interesting opportunities for different types of clients than we had traditionally in the past. Here we have an example. We're going to talk about this in the context of, say, the utility network. We're choosing that because utility network users are utility community. They're very heavy users of version management. In this diagram, this is a little bit of a architecture diagram, but we can see two basic things. Up on top, you see ArcGIS Pro. That's represented by that little dark blue rectangle up on top. Another thing that sits up at that level might be the managed SDK. This is the C# API that allows you to author add-ins and whatnot that you can incorporate into ArcGIS Pro. Now, this is a big simplification, but for this diagram, we're saying ArcGIS Pro sits on top of the geodatabase. The geodatabase, of course, is our traditional geodatabase that we've been developing since, way back in the late 90s when we began ArcGIS. And that will sit on top of this feature service client, or sometimes we call it the feature service workspace. It's had various different names, but the geodatabase sits on top of the feature service client. The feature service client is responsible for communicating to ArcGIS Enterprise through JSON. And this is represented using the yellow arrows in the diagram. Now, in our ArcGIS Enterprise, we've simplified it, and we're only showing 5 different services. We have the feature service that all of you have been using for some time. We have the new utility network service that was introduced as part of 2.1 and 10.6 to support our utility customers. In addition to that, the utility network constellation has a network diagram service. That's the way that you can generate and manage schematic representations of the data contained inside your utility network. We have the version management service. That's what we're talking about today and focusing on. That allows you to do everything related to the management and care and feeding of the various different versions in your system. And then finally, we have a validation service that allows you to run attribute validation rules or attribute calculation rules in batch mode and evaluate them for correctness on the back end. Now, what's interesting is each of these 5 services that I have depicted here, and again, not all of them are there. We have things like, the raster server, we have the map server. There's all kinds of servers out there that, as part of ArcGIS Enterprise, where they're just not depicted here. But it all sits on top of, again, the same geodatabase implementation as you see on the client. And that geodatabase will be communicating through our enterprise geodatabase workspace, or what was termed the SDE workspace, which will communicate on the back end through client server to enterprise geodatabases, such as the ones that Annie highlighted earlier, Oracle and Postgres and SQL Server and DB2 and SAP HANA. So at one level, this is one way to conceptualize the architecture. So these new services that we have the utility network service, we have the network diagram service, version management service that we'll talk about more today, validation service. Now, these things are enabled. Annie talked about this earlier when you're publishing. Okay, and here we're showing the server admin UI, and there you can see as one of the capabilities, the utility network is depicted, but also you have version management, which is 2 squares above it inside the select and configure capabilities area. Once the capabilities are enabled, of course, the REST endpoints are available, and the capabilities can then be called by the client applications through JSON. Now, the URLs for the REST endpoints, okay, nothing particularly special here. Just like map servers or feature servers, we have the 4 new types: utility network server, network diagram server, version management server, and the validation server. So they all follow the same naming convention, of course. Now, looking more at the version management server, here's one way to conceptualize it. We have the version management service up at the top. That's essentially our root. And there are various different methods that are hanging off of that. Things such as create for creating a version, delete a version, get version info, or purging locks. So the root, the version management service, has another resource that it points to, versions, which then will individually point to or can point to a collection of actual version resources. These correspond to individual versions inside your system. And you can see the other methods that are exposed at the version level, things that you would expect, such as start editing, stop editing, look at differences, do reconciliation, post, inspect conflicts, see the conflicts, various things like that. And the link here, there's quite a bit of really good online documentation detailing the REST API for the version management server, as well as the other servers that we've been talking about. Now, again, the root is the version management service. Root/versions is another resource inside this constellation. And then the final resource is the actual version instance. Now, versions, an individual version is referenced through a version GUID. Okay, every version is named, but every named version also has a version GUID, and you use the version GUID inside your URL requests, your REST requests, to identify the version that you're trying to do the given operation on. So, if we're looking at the root resource, the version management servers, here we can see from our documentation what the response syntax looks like. Right now, with the current release of the software, it reports its name, what type it is, what the default version name is, as well as what the default version GUID or global ID is. So there's the syntax, and as a simple example, you can see one below. Okay, so that lets you know essentially what the default version is, what its name is, and what its GUID is. Another interesting thing that you can do that not many people are aware of is you can ask for format or F equals schema. And what will that will do when you go against the root resource for our services, I think actually all services inside ArcGIS, is it will give you all kinds of useful information regarding things such as what are all the resources that are available, what are the operations that are available. For each resource, what are the operations on the resource, as well as things such as schema version. So it's an interesting way to get some quick metadata on your server if you go F equals schema off of the root resource. Now, if we look at the versions resource, that's basically just serving its purpose in life is just to be a container of actual version resources. So if you go and ask the versions resource, its response syntax will be a collection of version name and GUID pairs. So in this example, you see below in the response example, there's the default version with its GUID, and then Project A. I guess that's the only version inside this particular server. And you can see its name, Project A, as well as its GUID. So you go and you communicate with the versions resource when you want to see an enumeration of all the versions available inside the service. Now, if we go down to an individual version resource, we can also ask it, for some metadata. And this is the response syntax that comes back. It's actually quite useful information. You get the version's name, its GUID, the description that you've entered for it, the creation date of the version, the last time it was modified, the last time it was reconciled. If it is a child version, if it's a named version, what is the common ancestor date relative to default? Evaluation date, when was the version last evaluated? When did we run the validation server against it the last time? Is it currently being edited? Is it currently being read? Are there conflicts present? You can see stuff like that, the lock on or lock date, as well as the access privileges, okay? So that's the actual response when you talk to a version resource. Now, let's start looking at some individual operations that on the root resource. Something such as create version. Create version, very fundamental. You all know about creating version. But if you look at our documentation, it's fairly simple. It only has 4 parameters. One is the format, the output format, which is JSON. Otherwise, you can specify the name of the version that you're trying to create. You can specify the description, and you also provide the access permission. So down below, if you start looking at the URL at the REST request, you can see it down below. Things in blue and light blue are essentially the parameter names. And the orange things, the things in orange, are what you specify. So for example, format JSON. The version name, my new version. That's the name that we're trying to create. And we're going to make it a private version. Okay? So it's pretty simple. For those of you that have been doing REST and hitting services, there are no big surprises here. It's all fairly straightforward and logical. Now, what if we've created our version and we want to do some editing of the version that we've created? Well, the first thing we're going to have to do before we can update any of the data is we have to call start editing, okay? Start editing is an operation that is found on the version resource, okay? So once you create your version, it will hand back the method that we were talking about previously. Part of the response to create version will be the GUID or global ID representing the version itself that you have specified with a given name and privileges or permissions. So in this example here, we're going to assume that for the version that we want to be editing, its GUID corresponds to the thing that you see in green. Okay, so you can see in the REST request we have version management server /versions/ GUID of the version that I want to do start editing on. Okay, and that GUID is not enclosed in braces or anything like that. It's just a raw GUID. And then followed by the operation start editing, and then the parameters that you're going to specify are following the question mark. So you'll use the token for your session. We're saying the format equals JSON, and the session ID. The session ID is actually a GUID that your client application will create. And that is used to identify essentially the edit session or the service session that corresponds to this version on the back end. The client is responsible for creating the GUID. It can be any GUID you want, and that forms your session ID. Then when you do further communications, you will reuse that session ID to let the system understand that you are the correct client for editing or doing edit operations against that particular version. Okay? So pretty simple, pretty straightforward. Start editing. Next thing. Maybe in my client application, I go and edit some data. In this example, we're going to be creating a new record. Okay. When you're doing editing, you're actually going to communicate with the feature server. You're not going to communicate with a version management server. You're communicating with the feature server, and you're going to go through apply edits. That's shown up at the top of this REST request in orange. So you can see we're hitting the service and we're hitting the feature server and then the apply edits operation. Now, on the preceding slide, I was talking about that session ID. Remember, this is the global ID or the GUID that you create when you do your start editing. And it begins with, you can see on the bottom, 017 in this particular example. Well, here, to do the apply edits operation, the session ID is the same, or it's 107, I'm sorry, I messed that up. So the box in green is the same GUID that was used on the preceding slide when we called start editing. You will also specify the version that you're editing. My version, GDB version, that's the only thing that differs with the feature server when you're going to be editing version data. Okay, and my version, again, that was what we created earlier on when we did create version. So you're going to take the feature server apply edits operation and you're going to augment it with the session ID that you created, as well as the version that you are currently did the start editing against. Okay. One thing to note, you must retain that session ID. It's not possible to ask the server for what your session ID is. You must retain that on the client side. Now, say you get done with all your editing, I'm going to call stop editing. And let's say I went and hosed up my data. I went and screwed it up and I just don't like the edits that I did. Well, I'm going to discard my edits. So again, here's how we do it. Stop editing is an operation on the version resource, and it only takes 3 parameters. The format, that optional output format parameter, it takes again the session ID, and it also takes a Boolean argument save edits that says whether or not you want to retain the edits that you have done following the start editing call. So in this example, we can look down at the REST request on the bottom. Again, we're hitting the version management server. We're specifying the version. There's the GUID representing the version in the URL. And we're having the stop editing operation. The arguments are, of course, the token that's being used, the format, which is JSON, and again, the session ID that we had created earlier prior to calling start editing, 107, that large GUID. And then the final parameter, which is save edits, and here we're setting it to false. So what this will do is it will essentially unwind all the edits that you made following start editing in your version on the back end, and everything will be discarded. Okay? Now, what's interesting about all this, we were thinking, well, do we prepare a sequence of slides that detail all the 11, 12, 13, however many operations there are in the service? Well, it doesn't really make a whole lot of sense because you can see how simple and straightforward it is. Once you understand how to read the documentation and you understand what the parameters are and how to specify them, it's all fully documented, then you can see how you assemble them into the REST request. You have the URL with the operation followed by all the different parameters and their values. So it's pretty straightforward stuff. You shouldn't expect anything. None of the other operations that you see here are particularly difficult to configure or anything like that. It's just all more of the same. So we're going to leave it at that. There's no need to go through all the remaining 10 other operations at this level. But you can see it here, pretty straightforward. Let's talk a little bit about the Pro Managed SDK. Now, again, the Pro Managed SDK is basically the way that we are allowing clients to develop add-ins and other customizations of ArcGIS Pro. It's basically a managed code API. You'll use C#, and it's quite a bit simpler than what we exposed in the days of ArcMap. Remember, with 8.0, we released all those Arc objects, and there were a gazillion of them. I don't know, there were 5,000 different classes or code classes, tens of thousands of interfaces and methods. And it was cool at some level, but it was also very, very complicated and very hard to get your head around. So very purposefully, the decision was made during the development of ArcGIS Pro to provide a modern managed code API that simplifies the process of developing customizations of the framework in a very modern language, C#, and it only provides you with the methods that are necessary to write effective code. We don't give you 18 different ways to update the field value or a row object or a feature. No, we provide you with one. We don't expose 3 different class cursors. No, there's one cursor that you'll be using. So we've taken much of the pain of using raw ARC objects out by providing this managed API or managed SDK that you use C# to program with. Now, all that being said, so it's cool and modern and all that stuff, you know, mom and apple pie, really nice. How does it work architecturally? Well, down at the very bottom, still ArcObjects. ArcObjects is used to implement most of the functionality. On top of ArcObjects, we have a thin layer of C++ that's used to wrap the ArcObjects and actually allow us to create the managed API implementation. That's the green part. Now, the managed SDK that you're exposed to is actually the yellow stuff, the C# code. Okay, so that then allows you, the client application, to program against C#, where behind the scenes it's actually hitting ArcObjects, but you don't need to worry about that. All you need to know is the yellow stuff is very modern, very easy to use, and very powerful, and exposes best practices. We've tried to take away the pain as much as possible. Okay, what about it? Well, it's designed and implemented using standard C# patterns and idioms. So if you are a managed code developer, you will see all the different iterators and all the rest that you would expect with traditional C# programming and development. We're not trying to turn a C# developer into an ArcObjects developer. No, we want a competent C# developer to feel quite at home using the managed SDK and using all of our capabilities. It's minimally complete. It exposes only the essential abstractions. We try and limit the number of namespaces and all that. It is also very strongly typed, okay? You don't have to do a whole lot of object typecasting. And that makes it actually a lot easier to develop code, okay? The API is much more discoverable. And it's much easier for a user without looking at big E-size sheets of what the ArcObjects, you know, object model diagrams from back in the day looked like. It makes it much easier to author code. And it's also quite good with exception handling, being a very native C# style managed SDK. Okay, the managed SDK is really all about data manipulation. Okay, it does DML operations. It was purposefully designed to focus on data manipulation. That being said, it is not a data definition language. We did not expose classes or operations or methods that allow you to, say, create tables or to create feature classes or to alter coded value domains or do real schema level stuff. That is not intended to be supported by the managed SDK. If you want to do DDL type of operations, such as changing your schema, you need to use the preferred mechanisms, which is either GP tools or Python scripting, or you can alternatively use the Pro managed, you can use the Pro data management API. Quite a bit of work has been done there to make it an exceedingly nice experience to go and do your schema definition and modifications. So the managed SDK is not intended for DDL. It is purposefully designed for DML, okay? But do note that it is possible to directly call GP tools from C#, okay? And there are plenty of examples online, and here's a little code snippet that shows you the basics of being able to call a GP tool through managed code. Threading. Threading is important when you're doing managed development. And almost all the methods inside the core.data API do use, call them on the main SIM thread. That's really important to do that. There's a lot of good online help, and this is pointing you at a search string you should go for working with multi-threading in ArcGIS Pro. That'll give you a lot more details regarding what to do and when to do it. But the basic rule is keep things on the main SIM thread, okay? Versioning. Now, we're not going to be going through the managed SDK here in this presentation. There are other workshops at the Dev Summit that cover that in great detail with Rich Rue and the team. But what we're going to talk about here is the extensions that were made to support versioning and version management. Now, through the managed SDK, it does provide an API that works with both branch and traditional versioning, okay? And you can do the types of operations that you would expect, things such as listing all the versions that are available in a particular geodatabase instance, including the properties, connecting to versions, creating or deleting new or existing versions, looking at differences from a given version relative to default, operations such as reconcile and post. So all of this is exposed through the managed SDK. Now, here you can start looking at some of the bits and pieces. From a geodatabase class, you can ask for, first, is versioning supported inside this geodatabase? And you can see that's a method that returns a Boolean value. And if versioning is supported, then you can ask the geodatabase for the version manager. Version manager is a nice helper class that essentially it's a little bit like the root resource that we were talking about through the REST API. But again, it's sort of your gateway to individual versions. And you can see on the version manager being able to connect, create a particular version, being able to get a version that has a specified name, get a list of all the versions, or connect to a particular moment in time inside the geodatabase. Now, there are other things that you can do through other classes, such as the version class itself. On the version class, you can see up in the sort of northeast corner, there are things such as being able to alter the description of a version, being able to delete a version, to be able to get the creation date, get the description, the modification date, the name of the version, all kinds of things like that, as well as operations such as reconciling the version, where you pass in a reconcile description, which is a collection of properties to configure how you want the reconcile to be processed. What kind of conflict detection type you want, whether it's by row or by column. What kind of conflict resolution method do you want to have? Namely, if you find conflicts, do you want it to abort or do you want to allow it to continue? And then finally, there are conflict resolution types, favor the target version or the edit version. And you can also get the result back from your reconcile operation. Here's a little code snippet. Here's some more C# that shows you how easy it is. Of course, some of the details are omitted, but the key points are described here, where how you can go about creating a version, how you can reconcile and post a version, as well as finally how you can delete a version. And inside this code, of course, some of the details are omitted, but the most important calls are detailed there, okay? And as you can see, okay, we're connecting to a geodatabase, we get the version manager, from the version manager, get the current version, which is default, then off of the version manager, we're creating a version, a particular version, I think it's named CA, inside the description, and then let's see, connecting to it. Then we open data sets inside that particular version. We're figuring out how many features there are in a given feature class that corresponds to layer ID 0. Do some stuff, Then we can do a reconcile operation. We create the reconcile description, passing in the default version in the constructor, do the reconcile operation itself, get the result, do whatever we want to with the result, and then finally we're going to delete our version. Okay? So it's not that hard. Not that hard at all. Okay. What did we cover here, guys? Hey, wake up.
A lot of information.
Hey, clap your hands. Hey, wake up. Hey,
There you go.
Annie Sassadar kicked it all off with a terrific summary of what branch versioning is really all about. You explained a lot of the motivation behind it, a lot of the strengths. You didn't describe any of the incredible technical flaws and terrible things about it. You talked about the good things, correct?
Correct.
Okay.
Because we continue to improve this model.
Yeah, and that's very important. All the stuff that we talk about, all the things that we described are how they exist at this moment. However, like Annie is saying, we're working to enhance it. So, for example, what are some of the things that we're enhancing right now as part of our current development cycle? Is there anything that you want to talk to?
We've done the conflict detection. We've done the filtering of conflict fields, sets for the users. We are working on developing a custom role so that organizations that cannot handle the high-level privilege we currently need, they have another way to do the version management server. So these are the near-term work that we are looking to do.
Right. That's really cool. Not only is the user interface just getting better and better, but just the fundamental functionality is continuing to be extended according to what you guys are trying to do out there in your organizations. And Kevin, what about you?
So some of the things that we're thinking about with branch versioning are once you get these systems, like Eric said, a lot of the utility networks are moving towards using branch versioning. They're going to grow. And as they grow, we need to be able to deal with their size. And so some of the things we're talking about now are archiving and possible retiring of data in your branch versioning. And these are things that the teams are looking at in terms of how we present it, how it's going to be used by users, both in an online and offline manner. So a lot of the thought now is to looking towards the future as this data starts to mature. A lot of the folks who are using traditional versioning know these are pain points with their data. We understood that when we built branch versioning, and now we're trying to really deal with that part of it, which is the size of your data. And obviously performance. Everything we do today is based upon performance and scalability. We know that data is going to grow. So we're trying to think constantly about how we can improve our modeling, how we could adapt to more database technology, partitioning, et cetera, to allow us to take advantage of these types of technologies. But all in all, Esri is really trying hard to keep their eye on the ball, which is working with our users to understand the performance needs and dealing with those. So look for some of these things coming in the future.
Yeah, it's really interesting. You might think that given that the initial capabilities were released, several releases ago, a couple years ago, you'd think, oh, are you guys all done with the work? Are you now in maintenance mode? Gosh, I wish we were, because then I could go bowling or do something fun. But unfortunately not. We just have piles of things on our plate. This is work that you have brought to us, additional requirements and ideas that come from the idea side, or meeting you at Dev Summit and user conferences, or other communications that we have with your account reps and other people like that. It's a very active area, lots of ongoing work, and a very large and dedicated team is working on that. Like with our services, we continue to add new operations and all that, new capabilities to our service architecture, our ArcGIS Enterprise. You've probably heard from some of the other tech workshops during this Dev Summit about some of the really exciting future capabilities as we go toward microservices and supporting Kubernetes-based infrastructures and architectures and all the rest. And so it's a very active and fertile environment. Also, even in the Pro managed SDK, we've made statements about it's only for DML. We have heard some of you say, gosh, it would be really nice if we could do some basic DDL type operations. Inside my tool, it would be really nice if I didn't have to call out to a GP tool and I could just create a table with a simple schema. I'm not looking to go and define a network data set, a transportation model, or a utility network, anything crazy, but I just need to create a table. Wouldn't that be cool? So stay tuned. The team is paying a whole lot of attention and people are very dedicated and they love to see what you guys can do with all this stuff that we have fun developing. So in any event, there's a terrific amount of online doc on this topic. We've paid a lot of attention to it and a lot of good work has been put into it. So, and then there are other, of course, forums and whatnot if you're not getting your question answered or you see a weakness in the doc. So in any event, have a lot of fun with it. You can do a lot of cool things. You can use it through runtime, of course, being a service-based architecture. You can go create web apps. Create JavaScript that can hit these REST APIs, hit the version management server. Completely doable today. Or you can use some of our tricked out JavaScript SDK to make it even easier for you. So in any event, have fun and keep developing the cool apps and doing the great work. And stay safe, everyone. We'll see you later on then.